Cutting your electricity bill by 80% sounds simple: use less power, turn things off. Be more efficient, but anyone who has actually tried that knows it doesn't go that far. You unplug devices, you switch to LED lights, you become more careful, and yet, the bill barely moves. Maybe it drops a little. 10%, 15%, sometimes less. So when people hear claims about reducing it by 50, even 80%, the first reaction is obvious: that can't be real. And most of the time, that skepticism is justified, because reducing your bill isn't just about what you use. It's about how your entire energy system is structured, and that's where most people never look. They focus on behavior, using less, turning things off, managing consumption, but the system behind it stays the same, and that's the limitation, because if the system itself is inefficient, small changes in usage won't create massive results. You're optimizing on the surface, while the structure underneath stays unchanged. So the question shifts, not, can you use less energy? But, where is the energy being lost? Because energy loss is everywhere: heat dissipation, conversion inefficiencies, distribution losses, small percentages, in multiple places, and over time, those small losses add up. Now, here's where things get interesting. Some approaches don't try to reduce usage directly, they try to reduce loss, or improve how energy is handled inside the system. That's a completely different angle. Instead of cutting what you use, they try to make what you use more effective, and in theory, that's where larger reductions could come from. But there's a catch, because not all systems that claim this actually deliver it. Some rely on misunderstood concepts, others exaggerate what's realistically possible. So when you hear 80% reduction, you have to separate two things: the idea and the execution. The idea itself isn't impossible in every context. If someone replaces an extremely inefficient setup, or switches to a completely different energy source, large reductions can happen. But when it's presented as a simple add-on device, working in any situation, with guaranteed results, that's where the claim becomes questionable. And that's the part most people don't analyze carefully. They focus on the outcome, not the mechanism, because the mechanism is what determines everything: how the system interacts with your existing setup, where the efficiency gains actually come from, what conditions are required for it to work. Without that, it's just a number, and numbers alone don't explain reality. Here's the turning point most people miss: the real issue isn't whether you can reduce your bill by 80%. It's that most people don't understand what actually drives their electricity costs. So they jump from one solution to another, hoping for a big result, without understanding the structure behind it. And that's why the outcomes feel inconsistent, because different homes, different usage patterns, different systems, all behave differently. There's no universal shortcut, but there is a pattern: the more control you have over how energy is used, distributed, and managed, the more room you have to reduce waste. And that's where meaningful savings start to appear, not from a single claim, but from understanding how the system works as a whole. If you want to explore how some of these alternative approaches are structured, there's a resource in the description that breaks down the components, the setup, and what people are actually doing in practice. You can look at it and decide what makes sense for your situation. And if you want more explanations that focus on how things really work, without exaggeration, subscribing just keeps you connected to that, simple, clear, and grounded.